So in the previous video, we saw exponential distribution. Now we are going to see Poisson distribution. See, Poisson distribution is very similar to your exponential distribution. Both are actually like two parts of the same coin. Okay. So see, in case of exponential distribution, if we are interested in what is the number of events, means what is the timing of the event. See, for example, I will just give you an example. See, in the previous one, I will just change the data a bit. So let us say that there is this conveyor belt, and on this conveyor belt some items are being manufactured. And what are the item whatever the items are being manufactured, let us say that four items are manufactured in 2 minutes. Right, four items are manufactured in 2 minutes. If I say items are being manufactured in 2 minutes on an average, on an average, this is not exact, this is on an average. What can I say? Two items are manufactured every minute, right? Two items every minute. So what we can say, lambda is equal to what? Lambda is equal to 2 items per minute, right? This is what? This is our exponential distribution. This we are interested in exponential distribution. So in case of exponential distribution, what will be the kind of questions that they will ask us? They will ask us what is the probability that the next item is manufactured in 1 minute, or they will ask us what is the probability that the next item is manufactured between 1 minute and 3 minutes, right? So next item should be manufactured in less than equal to 1 minute, or it should be manufactured between 1 and 3 minutes, right? So here they give us the time and ask us how many times that event occurs. They give us the time frame and they ask us within that time frame what is the probability of that event occurring. Okay, what is the, not number of event, what is the probability of that event occurring? So what is the expected timing of that event? In case of Poisson distribution, what they do, in case of Poisson distribution, they ask us the number of event that can take place. For example, see, for example, they can give you something like this same data, that four items are manufactured in 2 minutes. Then they will ask you what is the probability that eight items are manufactured. What is the probability that eight items are manufactured? Okay, so see, this in this they are giving us you the total number of items. Here they are giving you what? Here they are giving you time, right? Here they are giving you time, 1 minute, 1 minute to 3 minutes. Here they are going to give you the number of items that are being manufactured, right? So see, whenever you get the question, generally whenever you get Poisson distribution question, it will be written in the question that it is Poisson distribution. So there is no problem about that. But always remember, if you have the same kind of data, you can also treat it as an exponential distribution. You can also treat it as a Poisson distribution, depending on what is being asked. For example, let us look at the question that we have been given for Poisson distribution. The number of printing mistake on each page of a particular book follows a Poisson distribution. So they have given us Poisson distribution. Whenever we have a Poisson distribution, we require only one important thing, that which is the mean. What is the mean that they have given us? They have given a mean of 4, right? Whenever you have Poisson distribution, we require one variable which is going to be mean. What is mean? Mean is 4, right? Then they have asked us what is the probability that a randomly checked page of a book will have at most one mistake? Means what is the question? In the question they are telling us that a book has been printed, and on an average each book has how many mistakes? Each page has how many mistakes? Each page has 4 mistakes. They are asking us what is the probability of at most one mistake. What is the probability of at most one mistake? When I say at most one mistake, what does it mean? It means that 0 mistakes are also allowed and one mistake is also allowed, right? At most one mistake, na? So 0 mistake is also allowed, one mistake is also allowed. So we have to find out probability of 0 plus probability of 1. So what is the formula for Poisson distribution? The formula for Poisson distribution is probability of x is equal to x, e is equal to e raised to minus m, m raised to x upon x factorial. You have to remember this formula, okay, for Poisson distribution. So what are these variables? E is e, m is your mean, and x is the value that you are interested in, right? So this is the value that you are interested in. So how can we find out? We have to find out what probability of 0 and probability of 1. So probability of 0 is going to be what? E raised to minus m. See, they have given us what is the average. They have given us average as 4 mistakes. It is given in the question only. E raised to minus m into m raised to x upon x factorial. So it is going to be what? It is going to be e raised to minus 4 into 1 divided by 1. And according to calculator, it is coming out e raised to minus 4 is 0.0183. 0.0183. Similarly, what is the probability of there being one mistake? E raised to minus m, m raised to x upon x factorial, right? So it is what? E raised to minus 4 into 4 divided by 1. So just finding that out, it is 0.0733. Okay, so probability of at most one is what? Probability of at most one is probability of 0 plus probability of 1, which is what? 0.0183 plus 0.0733. The addition of both is 0.0183, 0.0733, comes out 0.0916, which is 9.16%. So this is the probability of at most one error.